Hello guys and welcome back to 5 minutes of channel. In this video I want to talk about the new function of sensitive data tagging for zOS in 5 minutes of course. Do you remember the concept of pervasive encryption introduced with the launch of IBM Z14? A concept that involves the encryption of all data regardless of its state. A revolutionary concept that can also have its value because it leverages the powerful hardware capabilities on Z machines. Despite this, some auditors require concrete proof of the protection of sensitive data. In other words, it's not enough to say all data is encrypted. You also need to know where the sensitive data being encrypted resides in order to demonstrate its security. This means that encryption is indeed essential, but it is equally important to track sensitive data and manage access to it, as well as the evolution of its life cycle in terms of protection. What is zSDT? zSDT is sensitive data tagging on zOS that is a powerful solution based on machine learning and AI acceleration that identifies and classifies dataset containing regulated or critical information. It assigns metadata or tags to dataset to describe the sensitivity level or type of data. These tags can be consumed by security, by audit and governance tools to enforce content-aware controls. Why it is needed? Well, traditional zOS security solutions such as RACF protects dataset based on name and profiles, not content. So organizations require clear identification of where sensitive data resides due to the regulation requirements. Manual classification is error-prone and inconsistent. Compliance and auditability require standardized machine-readable metadata. Modern governance models expect content-driven security, not static rules. Organizations can protect their sensitive data through the process of automated classification in 5 steps. First, data discovery, to analyze dataset, to identify sensitive elements such as personal identifiable information, financial data, or identification numbers. Once these elements are detected, each dataset is assigned metadata tag that describe its main characteristics, for example, whether it contains personal information data, the type of data, financial, healthcare, etc., and its sensitivity level, height, medium, low. These tags are then used by security systems such as RACF or complementary tools to enforce targeted protection policies. Depending on the sensitivity of the data, this can include stricter access controls, mandatory logging of access, data encryption, multi-factor authentication, and conditional access rules. The process is not limited to the initial classification. Tags are periodically reviewed and updated to ensure they accurately reflect the current state of the data, especially when the data is modified, moved, or updated. Finally, the metadata tags can be exported to governance platforms, security monitor tools such as SIEM, or reporting systems, enabling centralized and transparent management of sensitive data. Implementing a content-aware data tagging systems aligns security controls directly with what each dataset actually contains. Instead of relying on static or manually assigned classifications, policies become dynamically driven by the true nature of the data, reducing misclassification and improving enforcement accuracy. From a compliance perspective, consistent and accurate tags make it easier to map datasets to standards such as GDPR, PCI DSS, etc., as well as internal governance frameworks. Auditors gain immediate visibility into sensitive datasets, enabling more effective correlation of controls and evidences. Operationally, automated classification cuts manual workload and configuration errors, increasing overall efficiency. A centralized inventory of sensitive data provides unified visibility across the mainframe environment, increasing risk management efficiency and accelerating incident response. Auditing also become more focused. Logs and report can focus on truly sensitive or regulated data sets, reducing noise and improving analytic quality. Standardized tagging further enhances integration with CIM, data governance tools, and monitoring systems. And finally, the tagging architecture is highly extensible, allowing the organization to adapt to new data types, emerging policies, and evolving regulatory requirements without redesigning the entire security model. Thank you for your attention, and if you want, subscribe on my channel and follow me in the next video. Bye bye from Luigi.